Polygons. Types of polygons. A regular polygon is a polygon with all sides and interior angles the same. Regular polygons are always convex. Uh, Convex polygons are the ones in which all interior angles are less than 180 degrees and all vertices point outwards away from the interior. The opposite of concave is convex. Regular polygons are always convex. Let us look at some definitions, properties and tips of polygons. Sum of interior angles in a polygon is 180 into n minus 2, where n is the number of sides. For a regular polygon, the total described above is spread evenly among all the interior angles since they all have the same values. So for example, the interior angles of a pentagon always add up to 540 degrees. So in a regular pentagon, each one is 1/5 of that, or 108 degrees. Or as a formula, each interior angle of a regular polygon is given by 180 into n minus 2 by n, where n is the number of sides. The apothem of a polygon is a line from the center to the midpoint of a side. This is also the radius of the incircle. The radius of a regular polygon is a line from the center to any vertex. It is also the radius of the circumcircle of the polygon. GMATH deals with some polygons. Let's look at some kinds of polygons. A quadrilateral is a polygon with 4 sides or edges and 4 vertices or corners. Different kinds of quadrilaterals are trapezium, trapezoid, isosceles trapezoid, parallelogram, kite, rhombus, rectangle, square. A parallelogram is a quadrilateral with 2 pairs of parallel sides. Opposite sides of a parallelogram are equal in length. Opposite angles of parallelogram are equal in measure. Opposite sides of a parallelogram will never intersect. And the diagonals of a parallelogram bisect each other. Consecutive angles are supplementary and add up to 180 degrees. The area of a parallelogram is A equal to BH, where B is the base of the parallelogram and H is the height. The area of a parallelogram is twice the area of a triangle created by one of its diagonals. A parallelogram is a quadrilateral with opposite sides parallel and congruent. It is the parent of some other quadrilaterals which are obtained by adding restrictions of various kinds. A rectangle is a parallelogram with all angles fixed at 90 degrees. A rhombus is a parallelogram but with all sides equal in length. A square is a parallelogram but with all sides equal in length and all angles fixed at 90 degrees. Rectangle. A four-sided polygon where all interior angles are 90 degrees is a rectangle. The opposite sides are parallel and congruent. The diagonals bisect each other. The diagonals are congruent. A square is a special case of a rectangle where all 4 sides are the same length. It is also a special case of a parallelogram, but with extra limitation that the angles are fixed at 90 degrees. The two diagonals are congruent. Each diagonal bisects each other. In other words, the point where the diagonals intersect divides each diagonal into 2 equal parts. And each diagonal divides the rectangle into 2 congruent right triangles. Because the triangles are congruent, they have the same area, and each triangle has half the area of the rectangle. So diagonal is square root of w square plus h square. where W is the width of the rectangle, H is the height of the rectangle. The area of a rectangle is given by the formula width into height. A rectangle can be thought about in other ways. A square is a special case of a rectangle where all four sides are the same length. Adjust the rectangle to create a square. It is also a special case of a parallelogram, but with extra limitation that the angles are fixed at 90 degrees. Squares, a four-sided regular polygon with all sides equal and all internal angles 90 degrees is a square. If the diagonals of a rhombus are equal, then that rhombus must be a square. The diagonals of a square are about 1.414 times the length of a side of the square. A square can also be defined as a rectangle with all sides equal, or a rhombus with all angles equal, or a parallelogram with equal diagonals that bisect the angles. If a figure is both a rectangle and a rhombus, then it is a square. Rectangle, 4 equal angles plus rhombus, 4 equal sides is equal to square. If a circle is circumscribed around a square, the area of the circle is pi by 2, about 1.57 times the area of the square. If a circle is inscribed in the square, the area of the circle is pi by 4, about 0.79 times the square area of the square. A square has a larger area than any other quadrilateral with the same perimeter. Like most quadrilaterals, the area is the length of one side times the perpendicular height. So, in a square, this is simply area is equal to s square, where s is the length of one side. The diagonals method. If you know the length of the diagonals, the area is half the product of the diagonals. Since both diagonals are congruent, this simplifies to area is equal to d squared by 2, where d is the length of either diagonal. Each diagonal of a square is the perpendicular bisector of the other. That is, each cuts the other into two equal parts and they cross at right angles. The length of each diagonal is s root 2, where s is the length of any one side. A square is both a rhombus and a rectangle and therefore has all the properties of both these shapes. Namely, the diagonals of a square bisect each other. The diagonals of a square bisect its angles. The diagonals of a square are perpendicular. Opposite sides of a square are both parallel and equal. All four angles of a square are equal. The diagonals of a square are equal. A square can be thought of as a special case of other quadrilaterals. For example, a rectangle but with adjacent sides equal, a parallelogram but with adjacent sides equal and angles all 90 degrees, a rhombus but with angles all 90 degrees. Rhombus is a quadrilateral with all four sides equal in length. Rhombus is actually just a special type of parallelogram. Recall that in a parallelogram, each pair of opposite sides are equal in length. With a rhombus, all four sides are the same length. It therefore has all the properties of a parallelogram. The diagonals of a rhombus always bisect each other at 90 degrees. There are several ways to find the area of a rhombus. The most common is base into altitude. The diagonals method. Another simple formula for the area of a rhombus when you know the lengths of the diagonals is the area is half the product of the diagonals. As a formula, d1 into d2 by 2, where d1 is the length of a diagonal and d2 is the length of the other diagonal. Trapezoid is a quadrilateral which has at least one pair of parallel sides. Base is one of the parallel sides. Every trapezoid has two bases. Leg is a non-parallel sides are called legs. Every trapezoid has two legs. Altitude of a trapezoid is the perpendicular distance from one base to the other. One base may need to be extended. If both legs are the same length, this is called an isosceles trapezoid and both base angles are the same. If the legs are parallel, it now has two pairs of parallel sides and is a parallelogram. The median of a trapezoid is a line joining the midpoints of the two legs. Here it is AB plus DC by 2. The length of the median is the average length of the bases. The median line is always parallel to the bases, and the median line is halfway between the bases. The median divides the trapezoid into two smaller trapezoids, each with half the altitude of the original. The usual way to calculate the area is the average base length times altitude. The area of a trapezoid is given by the formula h into a plus b by 2, where a, b are the lengths of the two bases, h is the altitude of the trapezoid. The area of the trapezoid is altitude into median.